use the question window. Feel free to raise those questions whenever you feel like. If we don't have time to address them at the end of the session, we will be sure to get back to you via email. And we will also send out the recording of the session, and the same recording will be available on our website for download. Now, I will go ahead and open today's session with a brief introduction to Nividus. Founded in 2011, we aim to help businesses work at their peak efficiency with our intelligent automation platform. We offer vertical solutions to help empower companies of all sizes. And one of the biggest differentiators of our platform is that RPA, AI, and process orchestration or local process automation capabilities are natively embedded within the platform. So this key differentiator helps us enable our customers to achieve end-to-end process automation and a competitive edge. We are also recognized by leading global research analysts such as Gartner, Forrester, and Everest Group. Okay, so now I'm going to hand it over to our speaker for today. Mark, over to you.
Yeah, thank you, Shaylee, for the introduction and the overview of Nividus. And I just want to thank all of you for signing into this webinar just to learn a little bit more about achieving operational excellence in manufacturing by using intelligent automation. Now, I know that as we progress through this particular webinar, that you'll find the approaches that we take to certain issues to be novel, and that I think you'll come away with some real potential areas of opportunity to apply intelligent automation into some of the challenges that your department or company faces. So before we get too far down the road here, what I'd like to do is start out by explaining what we mean when we talk about intelligent automation. Now, intelligent automation is a combination of three different automation technologies. The first being RPA, and robotic process automation is comprised of bots that will automate certain repetitive, mundane, menial activities. And it really focuses at the task level. So these bots will do things like copying information from one application to another, or generating a report from a variety of different fields and information stores within your organization. Now, orchestration, on the other hand, allows humans to participate in the process. So with orchestration and RPA together, bots and humans can work together to accomplish what needs to happen in order for your department or your company to run properly. Orchestration is also really good at going into various applications and different information stores and getting information centralized and functioning as a whole. Now, artificial intelligence is another automation technology that's inherent to our platform, and it enhances the capabilities of humans to make good business decisions, and it also allows bots to automate certain tasks that are traditionally left in human hands. So now that we've defined intelligent automation, let's take a bit of a deeper dive into some key artificial intelligence technologies that will absolutely positively impact your manufacturing operations. So today I'd like to look at a couple of different branches of artificial intelligence, namely machine learning and computer vision. Let's see how they can be applied to solving some real-world problems that we find are encountered over and over again in traditional manufacturing settings. So toward the end, we'll zoom in a little bit on how Nividus uses its AI capabilities in its intelligent automation platform to drive some really good value for the customers that it's working with. So to get started, let's talk about machine learning. Now, machine learning is a branch of artificial intelligence where computers learn from data and they improve their performance on a task without being explicitly programmed for that task. Now, what does all that mean? It seems like a mouthful, and it really is. But I think where we need to start is looking at a particular task. Let's give machine learning something that we wanted to do in a manufacturing setting. So let's have it quickly identify machine repair and maintenance events that are part of your manufacturing floor in an effort to reduce downtime. So we all know how disruptive maintenance and repair activities can be. So what we want to do is look at how machine learning can use data to improve your ability to identify those events. And we're going to do this within the context of an Internet of Things environment on a manufacturing floor. So now Internet of Things, or IoT, it describes a network of physical objects that have sensors and software and other technologies embedded within them for the purpose of connecting and exchanging data with other devices and systems over the internet. So this allows for things that aren't traditionally connected to the internet to be connected and to broadcast certain parameters and certain situations that they find themselves in. Now, for example, on a manufacturing floor, there are numerous things that make it up, and they can all be embedded with technology to broadcast information to other systems over the internet. And this is what we mean by the Internet of Things. That information that these objects or things are broadcasting will help us to really understand the environment of the manufacturing floor to a very, very granular level, just more completely than we ever have before. So that information that's being gathered by all of these different objects, that is absolutely perfect for machine learning. And there's really three reasons for that. The first is that information is very, very granular. So these individual sensors can measure and broadcast the movement, for example, of a product from one location to another, or maybe the operating temperature of a single light bulb, or the hydraulic pressure of a piece of machinery. So it's very, very granular and very, very individual to the object that is broadcasting and that's outputting this information. There's also a large volume of data. As you can imagine, with so many connected devices, you can get very, very overwhelmed with data very, very quickly. And with the amount of objects that can be connected, it's no surprise that that could be the case. But also, too, the data are extremely diverse. So there is data from all manner of things or objects with measurements. And these measurements lend themselves to understanding their proper functioning. So now that we have all of this data, it's a large volume of data, it's very diverse, it's very granular. What are we going to do with all this data? So remember the task that we had for intelligent automation and specifically for machine learning. What we're going to do is we're going to use this data to minimize the impact of machine downtime due to repair or maintenance activities. That's the specific task that we've been given. So you may have, for example, specific tolerances that shouldn't be breached. And if they are, it usually results in some type of maintenance or repair event. Well, that information is very, very important. Now, intelligent automation, what it can do is it can automatically monitor for these tolerance breaches. And it can automatically let you know when an object or a thing is in close proximity to a maintenance or repair event. Obviously, the more complex the machine is, the more data you're going to have to monitor and the more important intelligent automation is. So the data is all there. And the intelligent automation platform like Nividus has can make use of that data to interact with other systems. Like, for example, it could schedule an alert to relevant resources of the impending event. Just putting people on notice, just saying, hey, listen, this could very well happen. We're kind of reaching that point. Intelligent automation could also access other systems to order key parts and equipment from a warehouse or maybe even from an external vendor, and make sure that those parts and that equipment is present, making the maintenance or repair activity that much easier to deal with. But what about machine learning in particular? Because the intelligent automation portion of this is very interesting, but machine learning can take this to the next level. What machine learning can do is it can take a look at this data and identify novel and previously unknown patterns in that data that can be used to predict whether a certain maintenance or repair event is imminent. So those types of discoverable insights or correlations, they can be determined from historical data and applied to real-time data to make a prediction concerning the impending maintenance or repair event, the one that's likely to take place. Now, where machine learning excels is these patterns or these correlations usually are beyond human capability to identify. but they are very real. And when acted upon, these types of data will lend themselves to a much more efficient manufacturing floor. It will help you to identify those events, and in cases of maintenance and repair activities will result in less downtime. So that's what machine learning can do. So AI coupled with RPA, coupled with orchestration, that is the intelligent automation solution that will enable you to identify these areas of opportunity. Okay, so we took a look at machine learning. Let's take a look at another AI technology called computer vision, and let's take a look at it in the context of a manufacturing environment. Now, computer vision is yet another branch of artificial intelligence, and what it wants to do is it wants to train computers to interpret and understand the visual world. In other words, computer vision's goal is for machines or computers to take a look at a picture or a scene and to interpret it in the same way that a human would when engaging in the same task. But not only in the same way that a human would, but it's going to, when properly trained and properly implemented, eclipse human capability to interpret that particular image. Now, there are some very, very popular widespread applications of computer vision that are attached to the cameras on most smartphones that we have today. Like, for example, QR codes. So QR codes are everywhere, and they are processed through our cameras using visual cues to provide navigation to the resources to which that QR code points. So a cell phone camera can kind of take a look at a scene and say, oh, there's a QR code, and I'm going to interpret that QR code to go to the URL or to the app or to the resource that that points to. So another capability of computer vision is the camera that we use to take pictures. So for example, the boxes that we see drawn around faces of people that we want to take pictures of, it's a bit more of a complicated application of computer vision. But what it does is it takes a look at a scene and it says, oh, I see in this particular scene, I've got 3 faces. Now, those boxes are what we call areas of interest, and the computer vision algorithm focuses on those areas of interest in order to make sure that they are processed appropriately. Like when I'm taking a picture of my children in a particular scene, I'm going to want their faces to be in good focus. And so the computer vision algorithm will make sure that that special processing is going to be applied to those areas of interest. They are the most important parts of the image. Okay, so those are computer vision algorithms that are part of our cell phones. Let's take a look at the way we can apply computer vision to a manufacturing environment. Just like with machine learning, what we're going to do is we're going to give computer vision, the AI, a task to complete. So what we're going to do is we're going to give it a task to detect defects on surfaces. So in order for us to do that, once we have a problem that we're going to be solving, in order for us to do that, we need to build a model. And that computer vision model is going to be built with what we call labeled data. Now the labeled data that's going to go into this particular model are images of surfaces, some that are known to be good and some surfaces that have known defects upon them. So that labeled data is going to be built into this model, and that model is going to be used to examine a brand new surface. And it's going to be used to determine which surfaces are defect free and which one of those surfaces contain defects. So once the model is trained and tested and deployed, it can be refined with additional labeled data so that the model gets more and more accurate at determining these surface defects. Now, once that initial model is trained, through the use of machine learning, we can also have humans give input into the results of the computer vision algorithm. For example, at least initially, maybe computer vision will miss a particular defect, or it will call a particular surface good when it's not, or vice versa. Now, when humans give input, into the judgments or into the predictions that were made by the computer vision algorithm, that is how that model is refined, because that in and of itself is labeled data. So what does this labeled data look like? What could a labeled data set be comprised of? So for example, here we have a labeled data set where we have up above 6 examples of surfaces that do not have any defects on them. These are surfaces that are judged to be good. And we also have 6 examples of surfaces that have defects. Now, it's very, very important to get a good amount of samples. What we want to do is we want to make sure that the accuracy, the initial accuracy of this model is as good as possible. Now, it turns out that because we have been using computer vision in a variety of different settings, Nividus has the AI experts to not only determine the number of samples that are necessary for a good model, but we also can determine the proper framework under which that model should be built. So those are 2 key decision points that we need to make in order to make sure that that computer vision model is built and built appropriately and will have good accuracy right away. Okay, so now we have this model. What we can then do is build it, test it, refine it, and then we can show that model, the computer vision AI, photos of surfaces and have that model make a prediction as to whether these surfaces are good or whether they contain defects. Now, when we start to roll this out and when we start to test and refine this model, it's very, very important that we show it images that were not part of the previous model building exercise. If we do show them, show this particular computer vision model those types of images that were used for testing and for use for building, well, then it's not going to be accurate. So only when we show it new pictures and new images can we be assured that we're measuring the true accuracy of the model. So in this case, samples A and B are judged to be defect-free, while samples C and D are categorized as having defects. Okay, so now we have the prediction, we have the data. Now that we have this categorization of these surfaces, what are we going to do with that information? And this is again where intelligent automation comes into play. So here's a very, very simple workflow. So here we have an automated analysis of that surface. Now, what we can do is, in this case, we can present the intelligent automation solution with a decision. And that decision could be, okay, have I found a defect? If the decision is yes, there is a defect on this particular surface, what we can do is we can use orchestration to loop a human into the process to determine what type of defect is present. In other words, samples C and D are going to follow that particular branch. Now, if there's no defect, RPA can be used to, for example, enter A and B into inventory by accessing the inventory management system and inputting that information into it. Again, that's manual activity that would have to get done. And we, through the use of RPA, will be able to automate that manual activity. So when a solution uses artificial intelligence, in this case, computer vision, in the previous case, machine learning, and mixes it with orchestration and RPA, you can see how an entire business process can be automated from beginning to end. And that is unlocking the power of intelligent automation and really focusing on the use of artificial intelligence to enhance the capabilities of both humans and bots. Okay, so those are 2 good examples of the use of artificial intelligence in a manufacturing setting. How has Nividus seen this in the context of the customers that it works with? Well, the first example was one where we had a steel manufacturer and they needed a more efficient way to notify its vendors and customers about what they call high age inventory or non-confirmed orders. Basically, what they needed to do is they needed to liquidate that stock that was on hand. The customer's existing process, where the sales team kind of informs customers who may be interested in the inventory, it wasn't really targeted. and the communications were not effective. There was a lot of delayed decision making. The process really lacked the required intelligence to identify the specific customers that would be interested in the non-confirmed orders or the high age inventory. It just wasn't meeting their needs. So what they did was they approached us and they said, hey, listen, can we use intelligent automation to enhance this particular process? So what we did was we deployed intelligent automation and used artificial intelligence and machine learning models to train it on the customer's buying patterns. What we wanted to do was, through the use of machine learning, we wanted to identify customers that were going to be very, very interested in that particular stock. Basically, we were making a prediction saying, hey, listen, sales team, if you reach out to this customer, guess what? They're going to help you to liquidate that stock. And then what we did with that information was we identified the top 5 potential customers for each high age inventory and each non-confirmed order. And those customers and vendors were then made available to the team through Salesforce so that targeted communications could be made to them. Now, this was a much more intelligent process than they had before, where it was kind of scattershot before. They would just kind of use their own brains to kind of figure out, okay, this customer might be interested or that vendor might be interested. But here, we're driving this process with real business data. And that is the key. And it's not like people are sitting around crunching the numbers. Machine learning is doing it for them. And it's doing it more effectively than they could ever do this by themselves. So equipped with the proper intelligence, the sales team was able to move the inventory much more effectively and ultimately free up working capital. So we're saving a bunch of manual efforts, 100% data accuracy, machine learning, artificial intelligence, RPA, orchestration. It just doesn't make the same mistakes as we do as humans. And the process turnaround time was improved by over 80%. So a real win using intelligent automation. Another use case using intelligent automation is one that is a little bit novel in terms of computer vision. So we had a manufacturing firm that needed to process thousands of invoices per week. And these invoices were coming in from a bunch of different vendors and a bunch of different service providers. And they had 6 people that were literally looking at these invoices and transcribing the data from the invoices into SAP. So as you can imagine, again, us humans were really bad at these repetitive processes. There was a high risk of human error, and they were seeing substantial business losses because of damaged relationships with vendors as a result of these errors. So again, they said, hey, Nivedis, can you help us with this? We were more than happy to do that. And what we did was we used machine learning and computer vision to examine these invoices and do a couple of things. The first thing is we were able to categorize the invoices, and we were able to understand and fetch content from them with these invoices that were image-based. I mean, they could have been pictures, they could have been image-only PDFs. It really didn't matter to us because what we were doing is we were using computer vision, again, to examine that invoice and to identify areas of interest where we can extract content from that invoice and process it accordingly. So an invoice that's an image is just like looking at a picture. It's just like looking at a surface of a particular material. It is just another picture where we need to identify those areas of interest. And then using intelligent automation, we were able to access SAP, get that content that was extracted, and automatically feed that content directly into that ERP. So that's really RPA and artificial intelligence working together. Now, sometimes the bot would get an invoice that was a result of a bad scan or a bad fax. It would have some artifacts on the invoice, and that invoice would be hard to read. In that case, what the bot could do is, using our orchestration capability, it could loop a human into the process and allow that human to verify the content that was extracted. We want to make sure that the content that's extracted from the invoice is as accurate as possible before it got into the ERP. Now, in terms of the the benefits of this, you'll notice that there's 1,000 staff hours saved per month and 90% reduction in turnaround time. The manual efforts were reduced to a whole extent here. But you'll also notice the list of manual tasks that we were able to automate was quite a few. In fact, some of these tasks were best left to humans, but what we did was we used artificial intelligence to enhance the capabilities of our bots to automate those tasks that were human driven and human led in the past. So the bot was receiving the invoice, it was reading it, it was categorizing the invoice, it was notifying humans for content validation, it was transcribing content into SAP. And a really key capability here, what it was doing too, it was accessing the PO management system to validate the invoice against the PO. That's a three-way match right there. And that just helps to eliminate more manual activity, and it helps to drive some efficiencies in the process so that somebody doesn't have to go into that PO system, examine the invoice, and make a determination as to whether this invoice conforms to the PO that was used to generate it. So I did want to show you, though, the result of the computer vision algorithm and what it was able to do with this particular invoice. So this is a sample invoice, and what you're seeing here is our control center. It's a portion of our accuracy checking capabilities of the control center. And what you'll notice is there are boxes that are drawn around certain elements of this particular invoice. Those are the areas of interest that I was talking about before. Just like drawing boxes around faces, the computer vision algorithm is looking at this, and the AI is drawing boxes around certain bits of information that are very interesting and that should be extracted from this particular invoice. Now, again, we didn't have to extract all the content. In a traditional OCR setting, you'd basically be scraping all this content, and then you got to figure out what you have. Computer vision allows you to be very, very targeted with that. And artificial intelligence will read this invoice just like we would as humans and just zero in on those bits of information that we're the most interested in. Okay, so that is, those are two really, really good applications of our intelligent automation platform. So really, in summary, what I'd like to leave you with is artificial intelligence is an automation technology that is revolutionizing manufacturing processes. It is doing things with manufacturing that has never been done before. And AI allows for the automation of tasks that are traditionally left exclusively in human hands. And so that allows bots to act a little bit more like humans. And also, too, AI enhances human capability. Machine learning is a key AI technology to find those patterns in massive data sets to drive efficiencies. Computer vision can examine images and documents for areas of interest to unlock efficient processing as well. So machine learning and computer vision are huge, especially in a manufacturing setting. But AI is not the key to unlock everything. You really need an intelligent automation platform like Nividus has to make sure that RPA, orchestration, and AI are working together. Now, this may be something that you're interested in. It may be something that's really struck a chord with you and where you see some areas of opportunity. What we'd like to do is we would like to offer you what we call our Quick Start program. Now, this is a program that will have a guaranteed rollout of a trained bot within 3 to 4 weeks. Now, this is something where we will train a bot with a guaranteed rollout. It's going to be a fixed price with no obligation to purchase. In other words, we're going to roll this into production. We're going to solve a real problem for you. And once you see the automation in action, you will be, we're convinced that you're going to be thoroughly impressed with it, and you're going to want to purchase this solution. However, if it's rolled out and you're thinking, it's not really doing what I want it to do, well, then there's no obligation to purchase it. So all of the workshops, all the professional services, all of the software, that's all part of this no risk guarantee quick start offer. So if it's something that you would like to take advantage of, we'd be happy to talk to you a little bit more about this. So thank you for your kind attention. Shaylee, I'd like to turn it back over to you.
All right, great session. Thank you, Mark. I hope everyone found it insightful. We really appreciate you all taking the time to join us today. Our contact information is on the screen. Reach out in case you have any questions or are interested in our quick start offer, and we will get back to you shortly. We do have a great lineup of next webinars, and we hope to see you again in our upcoming sessions. Thank you again and have a great day.